Hello everyone, I'm Dr. Manju Gupta from Department of Chemistry, St. Aloysius College. Today I'm going to discuss remaining chemical reactions of phenols. The main class of chemical reaction of all aromatic compounds is electrophilic aromatic substitution reaction. What do you mean by electrophilic aromatic substitution reaction? An organic reaction in which hydrogen atom attached to the aromatic ring is replaced by an electrophile. Electrophile, that means electron deficient species, electron loving species. Electrophiles are positively charged or neutral species having vacant orbitals that are attached to an electron-rich center. Obviously, electron-rich species will attack on the electron deficient species. Due to electron donating hydroxyl group, phenol is more reactive than benzene. Benzene is also already susceptible towards the electrophilic aromatic substitution reaction. But when OH group is attached to the phenol, it becomes electron donating. It can donate lone pair of electron of oxygen to the ring and produce negative charge on the ortho and para positions. Phenol donates electrons to an aromatic ring and produce negative charge on ortho and para position. As you can see in the resonating structures of phenol. By electron donation, first it produces the negative charge on ortho position, then it delocalizes towards para position, then again delocalized towards the next ortho position. The resonating hybrid structure of phenol can be represented by the same structure in which two negative charges on the ortho positions and the one at para position. As the ortho and para carbon atoms are more electron rich, they are more likely to participate in electrophilic substitution reaction. Then that means any electrophile can attack on these electron rich positions. There are several electrophilic aromatic substitution reactions. Some main reactions are, first is halogenation reaction. Halogenation reactions started with the halonium ion X plus, like in bromination, bromonium ion Br plus act as electrophile. Halogenation can occur in two ways depending upon the types of the solvent used. For example, reaction of phenol with bromine, when it is carried out in the carbon disulfide at lower temperature, two products are possible, 2-bromophenol or 4-bromophenol. When the same reaction is proceed or carried out in the water or polar solvent, then all the three electron rich positions are brominated and 2,4,6-tribromophenol is formed as the product. Next reaction is nitration reaction. Nitration reaction is again the reaction of phenol with the nitrating mixture, concentrated sulfuric acid and concentrated nitric acid. Phenols upon treatment with dilute nitric acid undergoes nitration at lower temperature and to give a mixture of ortho and para nitrophenols. Mixture of ortho and para nitrophenols is separated by steam distillation on the basis of their volatility. In orthonitrophenol, both type of hydrogen bonding is possible, intermolecular and intramolecular. That's why its boiling point is higher than paranitrophenol, in which only intermolecular hydrogen bonding is possible. When phenol is treated with dilute nitric acid, it forms monosubstituted nitro compound. And when it is treated with concentrated nitric acid, the nitration results in the formation of 2,4,6-trinitrophenol, and its common name is picric acid. In the nitration reaction, the generation of electrophile, the electrophile is nitrosonium ion, which is produced by the reaction of nitric acid and sulfuric acid. Nitrosonium ion is formed, which act as electrophile and attack on ortho and para position. Next is sulfonation reaction. Sulfonation reaction is reaction with concentrated sulfuric acid. Again, which product is formed, it depends on the reaction conditions. At lower temperature, orthohydroxybenzene sulfonic acid is formed. At higher temperature, more stable para-hydroxybenzene sulfonic acid is formed. Next, aromatic electrophilic substitution reaction is Friedel-Crafts reaction. Friedel-Crafts reaction is the reaction of aromatic compound with alkyl halide in the presence of anhydrous aluminium trichloride. Then the reaction is Friedel-Crafts alkylation reaction. When phenol is heated with methyl chloride in the presence of anhydrous aluminium chloride, then a mixture of ortho and para-cresol is formed. In case of lower alkyl halide, when we take a branched alkyl halide like tertiary butyl chloride, then only one product, only para product is formed. Friedel-Crafts acylation reactions. Phenols, acylation reaction of phenols requires harsher conditions, that means higher temperature. Phenol forms a complex with aluminium trichloride and consequently its activity decreases and form a monoacylation product, orthohydroxyacetophenone or para-hydroxyacetophenone. This is the mechanism of the reaction, in which first it forms a complex with aluminium trichloride and then after hydrolysis it is converted into product. Next reaction is Riemer-Tiemann reaction. Riemer-Tiemann reaction is a type of substitution reaction. It is used for the ortho formylation of the phenol. Formylation, that means to produce or to introduce a aldehydic group in the product. When phenol is treated with chloroform in the presence of alkali like NaOH or KOH, an aldehydic group, CHO group, is introduced at the ortho position of benzene ring, leading to the formation of orthohydroxybenzaldehyde, or it is known as orthosalicylaldehyde. Mechanism of the reaction. Mechanism starts with the chloroform. In basic medium, first deprotonation of chloroform and it is converted into chloroform carbanion. This chloroform carbanion radially undergoes alpha elimination of chlorine and giving dichlorocarbene as the product, which is the reactive species of the carbon. Second part of the mechanism, formation of phenoxide from the phenol in the presence of base. Phenoxide ion is formed and then dichlorocarbene attacks on the phenoxide ion. This results in the nucleophilic attack on the dichlorocarbene, forming an intermediate dichloromethyl substituted phenol. This is intermediate dichloromethyl substituted phenol. This intermediate undergoes basic hydrolysis, and after basic hydrolysis it is converted into the product, which is orthohydroxybenzaldehyde or salicyldehyde. These are the steps of the mechanism. Next reaction is the Kolbe-Schmidt reaction. Kolbe-Schmidt reaction is a carboxylation reaction in which COOH group is introduced. A carboxylation chemical reaction that proceeds by heating sodium phenoxide with carbon dioxide under high pressure and then treating the product with concentrated sulfuric acid. The final product is an aromatic hydroxy acid that is known as salicylic acid. Mechanism of the reaction. In basic medium, first phenoxide ion is formed from phenol and then sodium phenoxide is allowed to absorb carbon dioxide at high pressure and high temperature, and there is the formation of an unstable intermediate. This unstable intermediate first undergoes proton shift, leading to the formation of sodium salicylate, and this sodium salicylate, when treated with sulfuric acid, it is converted into free acid salicylic acid. Next, aldehydic synthesis is Gattermann's aldehyde synthesis. Gattermann's aldehyde synthesis involves aromatic compound, formulation of aromatic compound by a mixture of hydrogen cyanide and hydrogen chloride in the presence of lowest acid catalyst, which can be aluminium chloride or zinc chloride. First, there is the formation of imine intermediate. This imine intermediate undergoes hydrolysis and form 4-hydroxybenzaldehyde. Remember, by Remer-Timmin reaction, 2-hydroxybenzaldehyde is formed. By Gattermann aldehyde synthesis, 4-hydroxybenzaldehyde is formed. In this particular reaction, in case of phenol, R is substituted by hydrogen. Next is Hoben-Hosch reaction. Synthesis of acyl phenols from phenols or phenolic ethers by the action of organic nitrides in the presence of hydrochloric acid and aluminium chloride. Now, the difference between the Gattermann aldehyde reaction and the Hoben-Hosch reaction. Only this, in Gattermann aldehyde reaction, HCN is used, and in this reaction, in place of HCN, any other organic nitrile compound like CH3CN or C2H5CN is used. Same in the first step. First, there is the formation of imine intermediate, and imine intermediate after hydrolysis, it is converted into phenolic ethers. This is the mechanism. In the first step of the mechanism, a nucleophilic addition to the nitrile with a polarizing Lewis acid forming an imine, which is later hydrolyzed during the aqueous hydrolysis to form a final aryl ketone. Next is Lieberman-Nitroso reaction. Lieberman-Nitroso reaction is the reaction of phenol with sodium nitrite and concentrated sulfuric acid. In this particular reaction, during the reaction, there is the formation of nitrous acid, which is responsible for the nitrosation reaction of phenol. First, it produces a deep green or blue color in acid medium, and again it combines with the another molecule of phenol and form a red colored dye that is known as indophenol. This reaction is also known as phenol-indophenol reaction. This red colored indophenol product becomes blue or changes to blue in the alkaline conditions. Next is the phthalene reaction. It is a fusion reaction of phenol and phthalic anhydride in the presence of concentrated sulfuric acid. It forms phenolphthalein. Phenolphthalein is a colorless solid, but when it is dissolved in the alkaline medium or NaOH, it produces pink color, and its pink color disappear in the excess of NaOH. This reaction is used for the detection of phenol in organic reaction mixture analysis. Next reaction is Ladler-Manasse reaction. Ladler-Manasse reaction is a type of condensation reaction. Condensation reaction is a type of addition reaction in which during the addition there is the removal of any small molecule. So Ladler-Manasse reaction is a condensation reaction of phenol with formaldehyde in the presence of base. This reaction is very slow and takes place at room temperature. For the condensation reaction of phenol and 40% solution of formaldehyde, it requires 6 days and formation of para-hydroxybenzyl alcohol and ortho-hydroxybenzyl alcohol. When ortho-hydroxybenzyl alcohol or ortho-hydroxymethyl phenol undergoes polymerization, it forms a linear polymer, and this linear polymer is known as nova leg. When this nova leg treated with excess of formaldehyde at high temperature, then this linear polymer undergoes cross-linking polymerization and converted into a cross-linked polymer that is known as bakelite. Bakelite is also known as phenol formaldehyde resin, which is formed by the polycondensation of phenol with excess of formaldehyde at high temperature. Bakelite is bakelite is a form of rubber which is used for the making of tires. Thank you.